friends, I hope everyone is fine and doing good. We are actually starting a new series of lectures for GATE, ESE and IPATE and other SSC exams. So basically today we are starting up SOM, Strength of Materials for Civil and Mechanical Engineering, and we'll be actually starting with some basic concepts. Today the concept of centroid axis and neutral axis will be covered up, and we'll be doing some questions for the clarity of the subject. Now what is centroidal axis and neutral axis? Let me start it with here, centroidal and neutral axis. What is centroidal axis? As all of you know, centroidal axis, it is a line passing through the centroid of the cross section. Now the centroid, it's also called as the geometric center because it is the arithmetic mean position of all points in the figure. For example, we have a variety of figures, like we have rectangular section, we have circular section, we have triangular section. So the centroid of this rectangular section will be, if it is the B width and this is the height or depth of this rectangular section. Now from B by 2 to H by 2, if you can draw two lines, and this will be the centroid. And similarly, the center of the circle itself is a centroid, or if you draw the two dias and then they will meet at a point, this is center of gravity or centroid. And for triangular section, from this point B by 2, if this I take the B. Now if you draw this from this point top, and you will get a point at H, if this is the H by 3, so, and this is 2H by 3. So this point, this is the centroid of this triangular section. Now the centroid axis, the central axis can be infinity in number, because through a point we can draw infinite number of lines. So they will actually, now in physical, if we talk about the physical significance of the centroid, if you cut the shape of this cross section and then you place a pin at the tip of the pin on the point where you have located the centroid, and this whole body will actually balance, and this will be actually balanced, it will be perfectly balanced on the tip of the pin. Now this centroid is also called as barycenter in astrophysics or astronomy subject. Now let's move to neutral axis. Neutral axis is a different concept. Neutral axis, it's a line or plane through a beam or plate connecting points at which no elongation or compression occurs when the beam is bent. So you have to remember this. When you have a bent beam, okay, and you have plane in the cross section where there is no compression, no tension, there is no strain, the value of strain along that line or along that plane at any point is 0. Okay, so this is a different concept. It's very different from centroid, so we cannot mix centroidal axis and neutral axis. Now let me shift my focus on neutral axis. Let me have a beam. If this is my beam and it is subjected to a movement, hogging movement, let this be M0. Now this is M0. So there will be constant bending moment over the section. Now this hogging bending moment will actually try to bend this beam like this. So you will be having tension on the upper side if this is the centroidal axis, and compression. So basically what I said, neutral axis is the axis where there is neither compression nor tension. If I draw the bending stress diagram due to this moment, if I draw the bending stress diagram over here, for example, I will draw it here. I will use this method. So this will be in tension to this hogging moment, and this will be in compression. So this will be positive and this will be negative. If I take compression as negative and tension as positive, then the bending stress diagram will be like this. Now it is due to the bending. Now this point where there is zero value of compression or tension, this point, from this line, if you draw an axis, okay, so you will be getting the neutral axis where there is neither compression nor tension. Now the position of neutral axis in a beam or in a section, it wholly depends upon the type of loading and intensity of loading as well. So here my loading was pure bending. Now if I, for example, let's calculate the value of the bending stress with the m0. For example, I will take m0 equal to 50 kilonewton meter. Let m0 be equal to 50 kilonewton meter. So due to the m0, what value of bending stress I will get, and I will use the flagellum formula, obviously, that is sigma is equal to my by I. My basic formula is sigma is by y is equal to m by I is equal to E by R. So I'll be using this part here. Now this bending stress, it is directly proportional to the distance y, that is the distance from any fiber you are interested in and the neutral axis. So this is y. So if I talk about y max, so that's the uppermost or lowermost fiber of the section, so where the bending stress will be maximum. So when I calculate about the sigma max, so I will use m y max, and I by y max is called the section modulus of the section, sectional modulus, okay, section modulus. So I'll be calculating it like this fashion. If the value of m is 50, and what is the value of y? So if the cross section is, for example, it's rectangular and this is a width, let this be 100 mm, and this is a depth, and let this be 300 mm. So what is the value of y? Y max will be 150 mm. So let's calculate it. 150 multiplied by, so what is the I, moment of inertia? So that is b d cube by 12. B is 100, d is 300 cube divided by 12, so 12 will go up. Since these dimensions are in mm and my new moment is in kilonewton meter, so I'll convert it into newtons and mm's. So 10 is power 6. Now this 300 cube, so it will be 27 into 10 is power 6. This will go. So 10 is power 6, 10 is power 6, it's gone. I'll be left with 9 here, 4. These two zeros and these two zeros will go, and 3 3s are 9, 3 5s are 15, 5 5s are 25 into 4 100. So I'll be left with 100 by 3. That will be equal to 33.33 ampere, megapascal or Newton per mm square. So this is the value of bending stress due to this movement, hogging movement alone. And if I draw the diagram, let me rub this first, and I will show you the diagram of the bending stress on the cross section. So if my cross section is this is the B is 100 and D is 300 mm. So the bending stress value of 33.33 MPa over here, and at the bottom as well, so I'll be getting 33.33 MPa. But this will be negative because it's compression. It will be positive because it is tension. So I'll be joining it over here in this fashion. So for tension, I will be drawing arrows away from the section, and for compression towards the section. So what is the position of neutral axis? It will be 150 mm from top, and from bottom as 150 mm, since the depth of the section is 300 mm total. Now since I said the if I change the loading conditions, the neutral axis can shift upwards or downwards. It will depend upon the intensity as well as the loading type. Now let my beam be subject to an additional direct load of, let's say, 500 kilonewton. Since these bending stress values were to the m0 value of 50 kilonewton meter alone, now I'll be interested in calculating the value of stresses, the direct tensile stresses due to this load of 500 kilonewton, and I'll convert it into the stress. So sigma direct, I'll write it here. Sigma direct will be 500 divided by the cross-sectional area, that is 100 into 300. So this I'll convert into Newton. So these three go, and 50 by 3, that is 16.67 MPa. 16.67 MPa. Since this is positive and this is tensile, it will be tensile for whole of this section. Now, and we have tensile part over here, so these two will be adding up, and I'll be getting a new diagram. So this will be 33.33 plus 16.67, that will be 50, I think. Yeah, 50 MPa. Okay, but at this point, at this part, we have compression and we have now tension due to this load. So these will be subtracting. So 33.33 minus it will be 16.67. 16.67. Join these two parts, getting it over here. So this will be in tensile. This will be compressive. So I am getting the point of zero stress over here. So this will be my neutral axis now. It has shifted downwards. By how much? Then we'll be calculating. Let this be x and this be 300 mans x. So using the law of triangles, we have similarity rule we'll use here. So we have 50 divided by 300 mans x equal to 16.67 divided by x. So while I'm calculating it, I'll be getting the value of x equal to 75.02 mm. Okay, so x equal to 75.02. Initially it was located 150 mm far away from the base. Now it's 75.02. So it has moved almost 75 mm downwards due to this load only. Now if I'll be increasing this load, this will go on shifting downwards. At maybe a point will come, it will at some stress value, maybe 1000 or 900 around, it will reach over this point, and above the value of above those stress values, it may go out of the cross section as well. So neutral axis is actually, it is not constant for a section. It may change due to the loading conditions. Now if I would have used if my load would have been compressive here, this direct load, so this neutral axis would have shifted upwards. So this is how neutral axis works actually. Now this type of problems we encounter in GATE as well as ESE. So I hope you guys would have enjoyed, and we'll be uploading more videos on SOM. So just subscribe and share our channel so that we also may get interested in doing this stuff. Thank you very much.